Hi, grade 8 students. This is day 29, page 571, numbers 11 through 23, the odds, but then also 27 and 29, if I can get my finger to go to the right spot. There it is, 29. Today's lesson is somewhat similar to a previous lesson that talked about volume of prisms and cylinders, but instead of prisms and cylinders, it's now pyramids and cones. The nice thing is, the formula is very similar. Previously, your formula for prisms and cylinders was that volume equals base times height, capital B. In other words, the area of the base times the height. Today's lesson says when you're doing this for cones and cylinders, all you really need to do at this point is add the part where you're multiplying by 1/3. Just a brief thought about that. Sometimes it's easier on a calculator to divide by 3 than it is to multiply by 1/3. So in my mind, I always think of this formula as being written this way. Capital B times H in parentheses, and then when I'm done, I divide by 3 because it just flows faster. Less keystrokes on a computer or calculator, what have you. But you can do it either way. It doesn't really matter. Remember that 1/3 is 0.3 repeating, 0.333333333. You cannot really just substitute 0.3 and plug that into a computer or calculator because you're going to be slightly off of the answer you're actually seeking, so keep that in mind. So how does this apply to this whole thing? Well, first of all, in the case of a cone, 1/3 times the area of the base times the height becomes 1/3 times pi r squared times height. Why? Well, when we look at this cone over here, what is the shape of the base? The shape of the base is a circle, right? So the area of a circle is pi r squared, so our area of our base becomes pi r squared in this formula. Now, in the case of a pyramid, it can vary. The base might be a square, the base might be a triangle, and the base might be a rectangle. So you kind of have to play it by whatever type shape the base of that particular pyramid is. So anyway, let's take a look at some example problems. I don't think this is too difficult, but let's see how this works out for you. Okay, here we have a cone. So using our formula over here for a cone, volume equals 1/3 times the area of the base. The area of the base is a circle, so that would be pi times radius squared. And our radius in this case is 5.5 squared. And then times our height, which in this case is that number 8. Now, you remember what I said before about 1/3, but I'm going to start here by thinking about where do I start in this whole grand scheme of things. Do I start here? No, order of operations tells us we've got to start with the squaring issue. So I'm going to take my calculator, turn it on, 5.5 times 5.5, and that gives me 30.25. If I can get my pen cap off, I got to do that part first. Now, the rest of this is multiplication, and we know that multiplication is a commutative. We know it's also associative. So now it doesn't matter the order we're going to go in. So I'm going to take 3.14 times 30.25 times, whoops, I pressed the wrong button. I got to start over, sorry. 3.14 times 30.25 times 8. And that gives me 759.88. And then I'm going to divide by 3. Remember I talked to you about that? I said that dividing by 3 is the same thing as multiplying by 1/3. Just makes it a little bit easier. And I get this as my answer, 253.3 cubic inches in this particular case. Let's try it the other way, though. Let's try it by using 1/3 in our problem. I'm going to clear this off, and I'm going to write in 0.33333, and I'm going to put in about 10 threes, and then I'm going to multiply it by 3.14, then multiply it by 30.25, and then multiply it by 8. And let's see what I get. I basically get the same answer, but I had to put in a lot of those 3's, right? Because I didn't want it to be 0.3. I wanted it to be 0.3 repeating. So that was an extra 8 or 9 strokes on the calculator. But whatever you're comfortable with. Whatever you're comfortable with. So that's our area, 253.3 cubic inches for that particular cone. Let's take a look at this one right here, where we've got, hopefully you can tell, it's kind of a bad drawing, but it's a square base, see that? 15 by 15 with a height of 12. Our formula says volume equals 1/3 times capital B times H. So what is the area of our base? Our base is 15 by 15, right? It's a square. Our height is 12, right? And we still got that 1/3 out front, right? Volume equals 1/3 times the area of the base, a square, times the height of 12. I happen to know that 15 times 15 is 225. So we're in essence having this problem, 1/3 times 225 times 12. So clear everything off on my calculator. I'm going to put in times 225 times 12, and I end up with 899.9999999999991. In other words, 900. 900 what? We're talking cubic inches in this case because it's a volume problem. 900 cubic inches on that one. Look at this next one. No drawing, just 2 numbers given to us. How do we solve this? The base area, we are told, is 19 square centimeters, and the height, we're told, is 21. We're not even told whether or not this is a cone or a pyramid, and somebody wants us to find the volume. Is that possible? Well, let's think about the formula. The initial formula for all of these problems is 1/3 times base times height, right? Remember we said that right over here? 1/3 times base times height. Doesn't matter if it's cone. Doesn't matter if it's a pyramid, right? Well, let's go back to this one. We know the base area is 19. We know the height is 21. Is this solvable? You bet it is. Just to mess with your mind a little bit, I'm going to do this as fractions. Yeah, watch this. 1/3 times 19 over 1 times 21 over 1. And I can do some cross simplifying. See that? Cross simplify 1 and 7 because I divided both of these by 3. The bottoms are now 1s. What's the top? 3, 6, 133. I get 133, and it's cubic centimeters in this case, isn't it? 133 cubic centimeters. Now, don't forget, another way to write cubic centimeters would be to write it like this, centimeters to the 3rd power. So sometimes you'll see it written like this. Oh, it's off the screen, sorry. Sometimes you'll see it written like this, cubic centimeters for volume, and sometimes you'll see it like this. But it still means cubic centimeters. Centimeters to the 3rd problem, to the 3rd power rather, is the same thing as cubic centimeters. Because what is volume? Volume is a measure of how much space we're taking up in a particular object, and space is represented by length and width and height, 3 different dimensions, right? Cubic centimeter has 3 different dimensions. Okay, let's take a look at some of the problems on the bottom of 570. 570. Look at number 4, please. Number 4 has a pyramid. And look at the base. What kind of base does that pyramid have? Its base is a rectangle of 5 by 4, right? So if we think about our formula, 1/3 times the area of the base times height, how do we figure out the area of a base that's a rectangle? Well, that's length times width, right? It's length times width. This is problem 4 on page 570, right? So I'm going to think in terms of 1/3 times the area of the base, 5 times 4, times the height of this shape, which happens to be 15, right? Guess what? I'm going to work this one out as fractions as well because I think it's faster. Look at that cross simplifying I can do. Divide by 3, divide by 3, answer is 100. Cubic somethings. Cubic what? Looks like meters in this particular case for problem 4, 100 cubic meters. Okay, let's look at number 5, shall we? We've got a cone. And they're trying to trick you on that one. They're trying to trick you because the cone has a radius of 3, and they give you 2 heights. One of the heights is a 4 centimeter height, and one of them is a 5 centimeter height. The 5 is actually what's called the lateral height of the cone because it slopes upwards along the side of the cone. The number 4 in problem 5, 4 centimeters, that's the height we want to use in this problem. So don't get confused by that. So we got volume equals 1/3 times, times the area of the base, remember? What's the shape of our base? Our base is a circle, right? So we're going to write in pi r squared. Pi is 3.14, right? What's our r squared? Our r squared. What's our radius? Our radius is 3, right? So we write 3 squared. And our height, which one of those heights did we say we're going to use this time? We're going to use the height of 4, right? The height of 4. And this is our problem that we solved. So we got 1/3 times, oh wait, what part of this do we do first? We do the 3 squared first, right? Times 3.14 times 9 times 4. Okay? This time I'm going to grab a calculator, clear it off, and I'm going to take the 3.14 times the 9 times the 4. That gives me 113.04. I just multiplied these numbers together, got that. And I'm going to take that and divide by 3. And when I do that, when I divide by 3, I get this number. Okay? Now, what if I did it thinking about this in terms of being 0.3 repeating? Let's try it again. Let's see what we get. I'm going to put 0.3 with a bunch of 3's after it, times 3.14, times 9, times 4. And what do you know? I pretty much get the same number, right? Now, I'm going to round this to tenths, 37.7, and I'm going to call it cubic whatever. Problem 5 is cubic centimeters. So there's our answer, cubic centimeters. Okay, go to problem 5. Problem 5 is a little bit different. Look carefully. What makes it different? They actually save you some work on problem 5 because they give you the area of the base. The base itself is a hexagon, I believe, right? And they tell you that the area of that hexagon is 48 square inches. So you don't even have to figure out the area of the base. They did it for you, and they tell you the height is 10. So whambity bambity, this is a pretty fast problem to solve. I recognize that this is, in my opinion, easier to solve as a fraction. This and this are both divisible by 3, right? And I get an answer of 160. 160 what? How about cubic inches in this particular case? Cubic inches, 160. Okay, hopefully this helps you to think through what you're going to be doing on this. Thank you for watching this video. Call me at 517-242-3138. By the way, Destiny's the first person to call me. Congratulations. 517-242-3138 if you get stuck on anything. Have a great day.